Good morning, Year 10. In this video, we're going to go over the solutions for the first, for the 5 questions for Week 3, Term 3 for Wednesday. The first question is based on the work we were doing yesterday, where we are asked to graph y equals 2x squared minus 3 on a plane using a table of values. So I've already given you the table of values just as a hint if you weren't sure which ones to use. Because it is a parabola where the highest power is squared, that's why we should probably do from minus 3 to 3, because it's going to be a curved line instead of a straight line, so we need more points to see how it looks. So the first thing I'm going to do is I'm going to use my calculator. I'm going to type in everything except I'll change the x to brackets because otherwise the negatives are going to mess with us a little bit. So I'm going to have 2 bracket minus 3 squared minus 3. When I type that into the calculator, I get 15. Then I'm going to do the same again, but for minus 2. When I do that, I get 5. I'll do the same again, but for minus 1. And I get negative 1. Then I'll do the same again for 0, which I get negative 3. And then when I go back to 1 again, it's going to be negative 1, so it's going to start bouncing back up again. So I'm going to write it like that. Now, I'm going to graph it on a plane, but it's important to look at, well, what are the values that we need? So we go up pretty high on the y values, but the x values, we just go from minus 3 to 3. So this is something I didn't talk about yesterday because I didn't want to make it more confusing. When we do our graph for our plane, so I'm going to do that here. Okay, got my graph. Okay, and I'm going to label the axes, and I'm going to shrink down my table of values because I don't really want it in the way for this. So I'm going to label the axes for the x-axis. I'm going to do the same thing. I'm going to have 1, 2, 3, nice and spaced out so we can really fit everything onto the graph. But then when I'm going up, instead of going up by ones every 2, I might go up maybe every 2 every 2. So I have 2, 4, 6. That just will help me fit a bit more onto the graph when I do it that way. I'll go minus 2, minus 4, minus 6 will be down here. Now you might be wondering, like, how can I have a different scale for my y-axis to my x-axis? And the thing is, as long as one axis is in scale with itself and same with the other, everything will be fine. So what I'll do now is I'll graph the ones that I can. So negative 3, 15, 15 is too big. I'm not going to be able to do that. But negative 2, 5, I can. So that's there. Negative 1, that's here. And 0, negative 3, that's here. Then 1, negative 1 is here. 2, 5 is going to be here. And I can't fit 15 on there. So I'm going to start at the middle and I'm going to go up, making a curve as I go. And I'll do the same the other way. Oh. You know what, I'm going to redo that one. I'm going to try and get as nice of a curve as possible. I find it hard to do the right-hand side because I'm right-handed. Yeah, and that's it. And I'm going to label it. So I'm going to say y is equal to 2x squared minus 3. So that's what it looks like there. Moving on, write the 5-number summary for 2, 4, 6, 7, 9, and 12. So for this, first of all, the numbers need to be in ascending order. They already are because I thought, hey, I'll be nice. But the 5-number summary. So there's a couple of things. We need our minimum number, our Q1, our Q2, which is actually the median, Q3, and our max. Okay. So the min and the max are the easiest. That's 2. I'll change colours for this. 2 and 12. Then we can't really do Q1 or Q3 until we get the median. the median is the middle number. But you'll see we've got 1, 2, 3, 4, 5, 6. The middle number's here. So I'm going to make a point there. That is the middle number. That is Q2. But so Q2, well, we can't actually say it's a number because it's not either of those numbers. It's not 6 or 7. It's actually the number in between. It's going to be 6.5. So I'm going to write 6.5. The way we find it, because sometimes it's not so obvious as 6.5, we add them together and divide it by 2. So we find the average or the mean of our the two numbers either side of the median. So in this case, it's going to be 6.5. Now, Q1 is going to be, I'm going to use a highlighter for this, the middle number of the first half. And then similarly, Q3 will be the middle number of the second half. Okay, so the middle number of the first half is 4. So that's our Q1. And our middle number of the second half is 9. So that's our Q3. And that's our 5-number summary. I find it a lot easier if you break it down like that, where you start minimum, maximum, and then go for the easiest ones first, and then you work your way down. Next, question 3. What is the gradient and y-intercept of y equals 3x plus 2? Well, you'll notice I haven't given myself much space here, and that's because I don't really have to do much. Now, this is a straight line. It's not a parabola. But the gradient, I'll just remind everyone, y equals mx plus b. So, m's the gradient. It helps if I can spell it, isn't it? Gradient. And the b is the y-intercept. So, we already have those. So, the thing with the x is the gradient, so that's 3. So I'm just going to say m is equal to 3, because everyone knows, like in maths we use m, that's gradient, everyone knows that, so you can just write it like that. And the y-intercept, which is b, I can say is 2. And that's it. For question 4, find the simple interest when $2,000 is invested at 5% per annum for 3 years. Well, the simple interest formula is I is equal to PRN. Not the compound interest formula, but the simple interest formula. So the principal is 2,000. The rate is 5% per annum, and N is 3 years. Now, as long as everything matches, so in this case we've got years and per annum, they match, they're the same thing, we can just put it straight into the formula. So interest is equal to 2,000 times 5% times 3, which gives us, don't forget the percentage when you're typing in the calculator, $300. That's the simple interest. Now, question 5, that's the last question, is about scientific notation. Now, we've talked about it a little bit, but not very much. So thought it'd be a good idea to pop it in the 5 questions. So scientific notation is when you have a number between 0 and 1, a decimal, or maybe not, times 10 to the power of something. So I'm going to rewrite 7870, but I'm going to put in a decimal place because that's where it is. Now, I want to get a whole number with a decimal place afterwards. So I'm going to move it once, twice, 3 times to get it to there. So I can rewrite it as 7.870. But because I've moved it, I need to multiply it by 10, because every time I multiply it by 10, I move it 1 space. And I multiplied it by 10 3 times. So I would write it to the power of 3. So if you typed in your calculator 7.870 times 10 to the power of 3, you'll get 7,870. So it's the same, but this is how we write it in scientific notation. I will say, though, that that 0 doesn't need to be there, so I'm going to change it to 7.87 times 10 to the power of 3. So that's how you write it in scientific notation. The important thing is that we still have a whole number that isn't 0 at the front, and it's less than 10. If it hits 10, that means we could have moved it again. So that's why it's just going to be 1 digit in front of that decimal. All right, that's it for the 5 questions today, and we'll move on.